Well, hello everyone. I'm very excited to be here in Berlin today, our first conference in Europe, right following the path of ZEIT San Francisco earlier this year. We're going to be making a lot of really cool announcements today, and we've invited a lot of our friends and community members to join us today and give really exciting talks afterwards. So let's jump right into our history for context of what we're going to be announcing today. So our mission for the longest time has been to make cloud computing accessible to everyone. And what that means for us is something very, very specific. We want to make it simple, we want to make it global, and we want to make it scalable. It all started for us with a command prompt. If Archimedes was alive today, I think he would say that in order to move the Earth, you would have to start with a command line. When we first announced Now, we had a very simple animation on our website that showed how Node.js deployments worked. And when I first started animating this, I thought about creating this really simple terminal that would show you how the system worked from end to end. Now, it turned out that terminal at the time didn't really exist. So I started just doing some CSS and HTML from scratch. And then that project later became what everyone today knows as Hyper. So Hyper became this extensible terminal built on web technologies, and it's now scaled to hundreds of thousands of users worldwide. Today, I'm very excited to announce the 2.0 release, and I'm going to go into some of the really exciting features. If you launched Hyper today, everyone gets a different experience. So what I'm showing here is my personal configuration that has a few plugins configured, and this is running on the new 2.0 release that features a lot of really cool and exciting performance enhancements. One of the challenges with Hyper has always been rendering different glyphs and making that really performant and scale across platforms and dealing with UTF-8 and different performance issues that, for example, make you think, why don't you just use a native terminal instead? So we're very happy to make a lot of really core improvements with 2.0. So the first thing is we've improved the fundamental underlying technology so it is smaller and leaner. So that's what we call the Hyper core. Most of the functionality moving forward that we add to Hyper will be in the form of plugins. So it's not necessary for us to keep expanding and expanding the core. The core itself has become 22% faster. So when it boots up, with a lot of web stacks, there's a penalty with that initial boot up time. But we're very glad that we've made it 22% faster, and we've compared the native terminal footprint in terms of memory and CPU consumption, and it's comparable to even the native terminals that ship with your Mac. We've also started porting Hyper to the Xterm.js engine, which gives us a lot of really awesome features. First of all, there's improved performance all across the board. There's better cross-platform compatibility, especially for Windows users. The rendering of Chinese, Japanese, Korean characters has been dramatically improved. Luckily for everyone that's created themes, and there's dozens and dozens of them. Oh, I apologize for, there's a little glitch. And it's back. Thank you. So we've improved rendering of Chinese, Japanese, and Korean characters. 100% backwards compatible with existing themes, and something that's been a major nitpick for a lot of users as under a lot of stress and there were a lot of I/O output, Hyper was not performing as well as it could, and we're very glad to announce that that's becoming way better. So today, you can access the 2.0 features by releasing and joining the Canary channel. So I'm going to invite our head of open source, Leo, who's also here from Germany, and he's joining us today, to talk to you about how to set up Hyper 2.0 from the Canary release, and how we actually made this happen, what the underlying technologies are, and some of the cool new features. So, Leo, please join us.
Hello, everyone. So that's my first talk, and, well, it sounds weird to hear my own voice. So I'll talk today about setting up the Canary channel. The reason why we made a Canary channel in Hyper is basically because Hyper is now such a big application that we can't just, well, release such big updates to everyone right now. Rather than that, we need to test them. So we need to make sure it works for everyone before releasing it. And for that, we built the Canary channel. We're using a software called Hazel, which I wrote. I'll show it to you in a second. It's basically just a tiny microservice running on top of micro. Let me switch the keyboard layout quickly. So, whoops. Okay, now we're back. So this is Hazel. It's basically a replacement for all of the update servers you already know for Electron. The great thing about Hazel is that it scales wonderfully across now instances, because it's not based on webhooks. Rather than that, it's based on pooling mechanism, which basically means that if you have multiple instances of the update server running, it will work just smoothly, because all instances will independently get the updates from GitHub releases. And that's another neat part of Hazel. But before that, I just want to say, for deploying it, you only need to run a single command, this one, and it will download the repository. You'll have to specify 2 environment flags, account and repository, and then it works. And so the great thing about it, why it's so neat, is that all of the releases that are cached in Hazel are basically just GitHub releases. And the only difference between public and Canary releases is that the Canary releases are marked as pre-releases on GitHub releases. So the only thing you need to do when having published Hazel, using now, for example, is publishing releases in GitHub releases and letting your builder software update the binaries. And then once it's there, you can mark it as a pre-release, and Hazel will pick it up. If you don't have it marked as a pre-release, let's say this one, it will just be picked up for the stable channel, and everyone on the stable channel will get it. So to get it in Hyper, you basically only need to, let's see if this works. Go to the Hyper config, and then at the line at the top here, update channel, there's a property called update channel which you need to set to Canary in order to make it work. And after having done that, you just close Hyper and restart it, which basically applies Canary updates. Well, it doesn't apply Canary updates, but the ability to get Canary updates. And now, once Hazel has delivered the update to Hyper, it will show a tiny message at the bottom. Actually, we'll wait for this to happen, and while this is downloading, I'll tell you about the background of Hazel. Another great thing about it is that since it's using GitHub releases, there's no need to cache anything. So the whole bandwidth basically goes to GitHub, which not only saves your bandwidth, but it's also much faster, because GitHub has a really neat CDN based on Fastly, I think, and it's globally distributed, so all of your GitHub releases will be available pretty much instantly. Yeah, so let's see if it's arriving here. You can see in the About window that's now on the Canary channel, but the current Hyper version is still from the stable channel, so the update should occur soon. Maybe we won't make it because the internet is very slow, so I'll just talk while it goes about what's also great. I should have a file here called, cjk.txt. As you can see in the stable channel, the Chinese characters are kind of crammed together, which basically means that the rendering isn't working properly. But on the version 2 release, we fixed it, so these and emojis will now work just fine. Yeah, so if you want to try it out, just go to your config, whoops, and set the update channel like this. And then you'll be automatically get canary updates, basically. Yeah, that's it.
I have no doubt that that update will show up shortly. Thank you, Leah. That was amazing. So with all of this in place, we're going to be able to iterate a lot faster on the core itself. Something that happened over the last few months, as Leo has said, is Hyper has experienced tremendous growth. And every time we release an update, the variables become wider and wider and wider, especially with Windows support. We recently had a few glitches on Windows, so I apologize to Windows users. We've realized that with great power comes great responsibility. With great responsibility comes the great need for canary channels. So that's really neat that Hazel makes it really easy. So the next thing we're going to bundle into Hyper is the command line interface to install plugins. So this has been available for a while in the form of HPM by our core member, Mateos. We're bundling it automatically with the terminal. So you're going to just have to type hyper I and a few arguments for your plugins. So for example, what I showed earlier in the video was the result of applying status line and simple vibrancy, which looks pretty cool. And I picked that wallpaper to highlight that. The problem with plugins is usually discovery and pre-visualization. So we're very excited to announce that we're going to be creating and deploying the Hyperstore. And this is what it will look like. So you're going to be able to go to hyper.is/plugins, and we're going to fetch from NPM all these different packages that are already available that have been tagged to be hyper-compatible. And this is especially cool for themes because you're going to be able to visualize ahead of time what your theme would result in. And there's a lot of really cool themes already there. The command line we are very passionate about because it's in our root DNA. It's what enables all this simplicity and all that power. And you can think of now as a command as trying to bridge that gap between development and consumption. So the end goal of everything we do and every product we create is that it's going to make someone's life better. It's going to be able to be interfaced by some human being out there. So to illustrate how we're trying to bridge all those gaps, I want to talk about the life cycle of a request. So imagine that you're going to ZEIT.co. So before we even get into talking about SSL, we have to talk about domains. So how do we even get ZEIT.co and where is it registered? So for that first layer, we announced inside ZEIT San Francisco that we made domain name acquisition also one command. So this is what it looks like for a deployment called ZEITberlin.com. So I believe it's actually live. I aliased it recently. I bought it for $15 very quickly. And I'm going to speed up. Spinner of death. So, and also the cool thing is, and you've probably experienced this when you work a lot with CLIs, is you can very easily aggregate them into bash scripts. So there's not too much of a distance between the command line also being a really powerful API. So one thing we're focusing on moving forward is making sure our APIs are as simple as they can be also for HTTP resources. So if you want to do that same thing with curl, it literally would also be one command. It would just go to domains/by. So you can think of now also being a very awesome API layer for things that are not even directly interacting with your team. So for example, you could run and buy domain names on behalf of your customers through our API. And now, in addition to that, one of our top requested features was, how do I transfer a domain name that is already in someone else's registrar? So we're also making now domain transfer, we're transferring one command. So for example, let's say I have aldi.com hosted on Namecheap. I would execute that command. I would enter the transfer code that the registrar supplies, very high security. because I verified with my email. I accept in my email, and literally there's no step 4. There's only celebration. So now domains transfer is going to be available in the CLI first to Canary users of Now Desktop, and soon to everyone else. And in some of our tests, it took as little as 5 minutes to move a domain from other registrars. So it's a very, very awesome experience, especially if you're concerned with centralizing all your domain names under one account and not having them scattered around the internet. After DNS, after domain names comes the DNS layer. So one of the things that we are notorious for is that for the vast majority of people that deploy with Now, they don't really have to worry too much about configuring DNS. And that's thanks to the Now alias command. Typically what you do is you deploy, you get a URL, and you alias it to a target domain. So what that's going to do under the hood is it's going to configure your records automatically if you configure the name servers to be ZEIT.world. So if you bought the domain with us, or if you configured the name servers to go to ZEIT.world, we do all of the DNS management automatically. So you really, on a day-to-day basis, only worry about aliasing your domain name. Otherwise, we also support, in the spirit of compliance and modularity, to add CNAME records that go to a specific location. Which means our DNS system is truly modular and programmable, or programmatic. Basically, you can use DNS to point somewhere else, or you can edit your records manually. So this is a very important thing to emphasize, because when something is very magical, in the words of Johnny Ive, it also has to give you the underlying power to modify it. And so this is something that we truly believe in. So every command that automates a process, we think it also has to give you the underlying APIs to make that process transparent for yourself. And likewise, you can query your API to edit your records directly. Our name servers, up until today, have been globally distributed and fully redundant. So this animation that we created for ZEIT.world was highlighting all the different cities that ZEIT.world was present in. And those cities were actually our name servers. So you could pick the locations that were closest to you, you pick the locations that were most relevant to your customers, etc. But what happens sometimes is you don't even know what your major regions are going to be, or you don't want to select ahead of time, you just want to make it completely dynamic and completely scalable worldwide. So how do you even get to select which ones, or what is the right name server to pick? That was a problem until today, and we're very excited to announce that ZEIT.world is becoming Anycast ready. For those of you that are not familiar with Anycast, in addition to introducing 6 new regions, just like we had earlier with the different cities, it's no longer necessary for us to decide when you're configuring your deployment or your domain name what DNS resolution servers you want to use. It's completely automatic, completely zero configuration. And obviously this sounds great. So anywhere in the world that you are, we resolve to the next most geographically close cluster. So it should be faster. So we set out to try to demonstrate how much faster it would be, and we found really great results. So compared to ZEIT.world before, the new Anycast-ready DNS system is up to 11 times faster. So we decided to run some tests with DNS benchmarks across many different compute regions, and we found improvements from 11 times faster to 9 times faster. That's to 6 times faster. It's very fast, I swear. Unlike this HDMI connection. So 1.5 times faster from Australia, for example, and London. Oh, there he goes. Perfect. And Germany. Germany. Brazil, unfortunately, for our South American customers, it's not that fast yet, but we're working on it. Iowa and South Carolina, Virginia, and Oregon, way faster as well. California was kind of our starting ground, so it's 1x faster. I'll take it. And we've verified this data across multiple existing cloud infrastructure providers. We're very, very pleased with the results. So following this idea that you have automatic DNS routing, you no longer need, obviously, to select specific cities. So we came up with the simplest naming scheme you could possibly think of. Whenever you configure your name servers in the future, or whenever we automatically configure your domains on your behalf, just remember the alphabet. A, B, C, D, F, .world are anycast ready, and they represent 16 physical locations right now, backed by 200 name servers. It'll be completely in production starting on October 15th, and I can imagine some people starting to sweat. So it's fully backwards compatible. You actually don't even need to change your existing name servers. But for all new customers, we'll encourage them to select the new list. After DNS comes the load balancing layer, which involves, obviously, routing requests and routing users around all the different availability zones. So now offers this out-of-the-box load balancing, encryption, and auto-scaling on this layer. So for example, when you deploy and we scale your deployments, we distribute them across different physical availability zones, so that if one went down, you wouldn't have to worry about it. Encryption is automatic as well, so when you run now alias, we produce certificates on your behalf so that you don't have to terminate SSL directly inside your deployments. And we also allow you to go a step further into the load balancing layer to map different URLs and different microservices. So imagine that you have a website composed of different individual deployments that you wanted to aggregate into one unified interface. You translate that mapping that you already have in your head to this simple configuration file, and you run one command. So when you configure those rules for your alias, you map path names into specific deployments. So the next logical step is, now that we have a multi-region DNS server, and now that we have seamless auto-scaling and load balancing, is to load balance across regions. So starting today, we're going to be offering instant multi-region serverless deployment. What you'll have to do is run now, and follow with now scale deployment, and you pick the region that you want to enable your deployment inside. Every deployment becomes universally and globally addressable. So consider my deployment at now.sh. If you enable it in multiple regions, no matter where you are in the world, we'll route you to the correct one based on the lowest amount of latency possible. In addition to that, we're actually giving you specific URLs to query a cluster to check for example, latency, health, etc. So in this case, if I add .sfo.now.sh, I would be querying the San Francisco cluster. And it can do the same for going to Belgium. The really cool thing about this is, if you know the major airport codes, we're probably going to have a cluster there pretty soon. So for now, SFO and Brussels, we're going to be demonstrating today. Which also, by the way, gives you effortless distribution across multiple infrastructure providers. So our San Francisco one is running on Amazon Web Services, and our Brussels one is running on Google Cloud. So if there are any major reliability hiccups with one of the areas, we can easily fall back and fail over to the other one, which to you translates into increased reliability at a lower cost. So for the next demo, we're going to be shuffling some deployments around the entire cloud. So I'm going to invite our lead developer, Jarmo, who made multi-DC now possible. Thank you.
Thank you. Hello, everyone. So let me just put this mic away. OK. Gosh. OK. So for these demonstrations, let's imagine that I'm at our office in San Francisco. So for this demonstration purpose, I'll SSH to the host there. OK, here we go. So now I'm connected to a machine that is hosted that is running in San Francisco. So let's go ahead and deploy Ghost, the blogging engine. And all it takes is to run a single command now. And here you can see we actually connected to the closest cluster, which is in this case San Francisco, and we are running the build and starting the deployment there. And now that the deployment is complete, I can go ahead and view the page. And here we have Ghost running now in San Francisco. And Ghost is a blogging platform written in Node. And while it's working pretty well, it seems a little bit slow. So let's look into the deployment inspector in the network tab. So here we are trying to find the root page, which is this one. And we can see the page load is taking about 1 second. Let's try it again. 900 milliseconds, 800 milliseconds. OK. It's reasonably fast, but I mean, it could be better. So now all I need to do is actually run one command, not the clear, but no scale, as we all know. But instead of just specifying scaling rules, I can actually scale to another region. OK. And here we can see it's already running in California, USA. And now we are copying over the whole deployment from San Francisco to Brussels, which is the closest data center to us here in Berlin. And well, it takes a moment to copy it there. We are actually copying the full deployment, the state, everything. And once the command completes, we have knowledge that the same replication settings are present in Europe, in the Brussels data center, and in the San Francisco data center. Let's give it a moment. OK. And now, when I open the same URL again, if the internet works, let's try reloading it. OK. And now we can look into the deployment inspector in Chrome, and we can see the request time has been brought down from 1 second to 280 milliseconds. And also, we can inspect the deployment by curling it. Oh, we have a weird keyboard layout. Let me fix that. And here we can. Oh, I'm running it in the US cluster, in the machine in the US, so it connects to San Francisco. And when I run the same command locally, here in Berlin, we can see it should resolve to Brussels. Here we go. Thank you. And let me introduce Guillermo back to the stage.
Awesome, thank you. So I'm going to take this back. Thank you, Jarmo. And I want to do a quick recap of what just happened because there's a lot going on. So by combining ZEIT.world with now deployments, we've been able to automatically route everyone to their nearest location at 2 crucial times: development and consumption. So your customers resolve DNS lookups faster by using ZEIT.world and get automatically routed to the nearest now cluster. Now, it's up to you to decide where in the world you run your deployments. And it's also up to you to decide For example, how much you want to cache, where you place your databases, etc. There are a lot of variables involved, but we give you the full control to distribute your deployment everywhere. Similarly, we're using this same technology ourselves to power API.ZEIT.co and ZEIT.co itself, which means if your team is distributed, for example, and they're deploying from several different locations in the world, their experience with the Now platform will be faster in itself. It's a little meta, but it enables a lot of faster iteration, and it makes your team happier because they're not traveling across the entire world while they're iterating on the product. Something that I mentioned earlier is that we also give you a specific access into each location. So what we decided to do with the top-level URLs, instead of redirecting somewhere or giving you a blank page, was to give you some insight into what that region looks like from where you are. So if you go to sfo.now.sh or brussels.now.sh, you're going to see some interesting results. So let's just go there really quick. I need to use this device. Any typo can be blamed on the keyboard layout, although right now it's the US keyboard layout. So meanwhile, I'm going to also open. Okay, Brussels is way faster. I like it, as if it was struggling. Okay, so Brussels has a latency. We're about 300 kilometers away, and it has a latency that, depending on our mobile connection, oscillates between, I would say, 20 milliseconds and now we're saying 200 milliseconds. If you have a stable connection, you should probably see from here, Berlin, 20 milliseconds guaranteed or your money back. Don't hold me accountable to that. But for California, we're seeing a best case scenario perhaps of 200 milliseconds, 300 milliseconds. From our clusters, and something interesting to point out is we have a higher performance link between clusters. So what happens if you're accessing a deployment from Europe that is hosted in SF, you're actually going to get better performance even if you haven't scaled it everywhere, because we have a high performance link between clusters. So what that means in practice is if you just start using Now today, even if you're not concerned about paying for multiple regions, you'll get better performance from everywhere in the world. So our intention is to take this concept that we're proving between these two paths and take it everywhere. So if you have an airport near you, we'll probably be there sometime soon. Even if it's private and a minor airport, we'll be there. So ZEIT.co itself is hosted on Now, which also means that when you're interacting with the website on a day-to-day basis, it should be a lot faster as well. So what we've done to accomplish this is we've replicated your metadata all over the world. So that gives you an extra layer of redundancy and lower latency when performing reads from many different points of the world. And Now offers static and dynamic deployments with the same API. You already know this. So if you have a package.json file or a Docker file, you can run it on Now. But if you just have static files like assets or what you typically use as a CDN or just, for example, even a single image, you can use Now in the same way. So you can now think of our platform as a CDN that works across all platforms in terms of programming languages and frameworks, all forms of execution, which means it can be something static or dynamic. And I think this is the major departure that we're taking. The concept of CDN has always been associated with a static cat video or GIF. But now we're extending that to offer any sort of high workloads or any sort of dynamic execution capabilities. The next layer is itself code execution. We're introducing a brand new API for performing deployments and uploading your code, and a revamped Now CLI. So we've simplified the process of deploying. Before we had two different APIs for performing a deployment, what we call the instant API, and an API that relied on uploading your asset files or in your source files ahead of time. What we wanted to do here was provide one simple unified API that gave you that range of possibility. So you can deploy anything that you want with one RESTful API call. You can inline the source code directly, Or you can use our upload API to only upload the bits of code that have changed. This is very important in the context of continuous integration because the vast majority of files don't change. And that's going to become even more relevant in the future for builds. So while the vast majority of files don't change, you want to use the upload API to get the least amount of code to us that we need to build and execute your code. We've also revamped our API documentation. We've made it offline friendly. This is going to be rolling out in the next couple days. And we will give you access and detail to every single capability of our API with versioning in itself. So for example, for deployments, you're going to get V1 and V2. We're also introducing signing with ZEIT. When you implement the OAuth v2 APIs, you'll get a pop-up that looks like this on top of your existing applications. So for example, let's say that you were to code an online IDE, and you wanted to integrate now deployments to said online IDE. You would present your users with, this is just hypothetical. There's no presentation later today about this. So you would present your users with a pop-up like this. They would log in. They would grant access right now to your account. And then that third-party website can now deploy on your behalf, which is a really powerful concept. Finally, we're very excited to announce new capabilities for code execution itself. We've been working on a project we codenamed Atlas. We've revamped our backend architecture entirely for really fast execution with precise resource definitions. So when you start scaling to hundreds or thousands of nodes, you start realizing that there's a give and take between optimizations that you could make to your code or just optimizations that you could make in terms of running more instances. So up until now, we haven't given you the insight or power to tweak those knobs in terms of allocation. Moving forward, we're adding the capability to decide how much memory, how many CPUs, and for how long you want each specific instance inside a now deployment to run for. So that translates into deciding the CPU count, RAM allocation, and the time to live of a specific deployment. So let's say that you have a Java application that takes a very long time to boot up. It wouldn't make sense to make the time to live short because it would be paying a very big penalty whenever we have to come back and relaunch it or scale it. So you will, moving forward, have access to tweak every single one of these knobs without giving up on the simplicity of the Now API. So for the vast majority of workloads, you just run Now, but when you start to optimize and when you start to get precise definitions of resources, you'll use Now JSON. So this gives you not only control over the actual execution capabilities, but it'll give you control over the concurrency primitives that the cloud gives you automatically. So let's assume that you have one thread that can only execute a single thing at a time, can only process one request at a time. You can now hint Now so that it does the management of your deployments and instance propagation based on that concurrency limitation. So what is the max concurrency that a certain instance can hit before we have to scale? And this is really interesting because we can now expand the Now platform to perform any arbitrary job workload. So while everything exposes an HTTP API, and we think that that's a really great thing because, for example, it gives you access to web feedback, it gives you access to health endpoints, it gives you obviously access to websites and web services. Sometimes you might just want to run 1,000 copies of a specific workload. So by tweaking the concurrency, you take away the burden of managing the concurrency inside your code. So instead of having to be aware of all the nodes that are running in a cluster or setting up different sorts of swarm architectures, we'll give you the ability to decide what your application needs in order to scale. So the default value will be something that we determine automatically so that we consider the best fit for your application. But if you want to customize that because you're confident about the capabilities of your code, you'll be able to do that as well. So Now gives you the freedom to support any programming language, any framework, any type of deployment, but we're now focused on also providing the precise control for any concurrency model so that every programming language actually runs efficiently in our platform. To learn more about all these upcoming features and to recap and to learn about how to download the canary releases of everything that we've introduced today, please join us at ZEIT chat. I'm sure many of you are already there. And I'm very thankful. Please stay tuned for all the awesome presentations that are coming later today, some of which are going to highlight some of the new features that we announced. And thank you so much.